and so on. Focus of this video will be on two particular kind of search algorithm, which is linear search and binary search. And the idea of both the search algorithm is to explore through search space of numbers, or it can be word, but the more emphasis will be provided on the numbers, but the idea can also be extended to word as well. But there are different searching methods which can be covered later in the course. Now the only focus of this number, linear and binary search, will be on the numbers. Now, as the numbers can be infinite, so the range of the search space is from minus infinity to plus infinity, or basically saying that set of all real numbers. Now, how this search algorithm, linear and binary search, are operating on the set of real numbers can be looked through an example first, and then the pseudocode of that algorithm will be discussed, and then the comparison of the time complexity and space complexity of both the algorithms will be done. So let's say now numbers can have the decimal value as well as floating value. Now, concentrating on the decimal part of the real number to understand how the linear search and binary search are working, and this idea can also be extended to float value as well. So this will give us a complete idea of how the search algorithm actually works. So this video will only focus on the decimal value, but can be extended to float as well. Now let's look at the example or idea of how linear search actually works. So let's say the numbers are 2, -1, -100, -100, 10, let's say 50, and 1020. 1020. The stages in any search includes two parts. First, a query is asked. So in query, the question is about what to search. And then a comparison has to be made. Comparison of the query, related to query, comparison has to be made. So these are the stages of any search algorithm. And how this idea is being explored in linear search or any search algorithm is to be looked. So linear search basically means you ask a query, like let's say what to search. So the query for this set of numbers is 5. Let's say 5 is the query. Another query can be to figure out whether 15, 150 or 15 is present in the set of numbers. So these are the queries. Now then comparison has to be made. How comparison is made in linear search is by comparing 5 with each number present in the set. So 5 is compared with 2, 5 will be compared with -1, 5 will be compared with minus 100 and so on till the complete set of number is explored. So that is the idea of linear search. If a pseudocode for this method has to be written, then the idea is simple. First, query has to be asked. Now query is like reading a number, reading an integer. This is basically a query. And then comparison has to be made. How comparison is made? It is made by comparing each element present in the array. So this has to be executed for the complete set of elements. So loop is to be worked out. If let's say the array is named as A, or it is better to include in the function len search A, comprising of all the numbers, let's say minus n to plus n, where n is the input or range provided by the user. Query, so let's say x is the value that has to be searched. If a of I is equal to x, then one can say result is found. Else skip, continue towards next number, and this is continued till the end of the loop and for loop and end function. Now let us try to figure out the time complexity for this problem. This will be big O of 1 and this will be executed in big O of log of big O of n. Time complexity of linear search is big O of n, where n is the set of inputs. The space complexity for this is, as there is no additional array or any data structure used, this becomes big O of 1. Now, the idea of linear search is clear, but can we make it more efficient? So what can be improved in the search stage? Query cannot be improved. Only thing that can be improved is the comparison. What if the number of comparisons are reduced? So in that way it will become more efficient to use. So that is the idea of using binary search. So binary search, bi means 2, and so this is basically searching in two halves. Searching in two halves. If it was ternary search, then searching in three halves. This, so basically it can be n array search where n is greater than equal to 2. Now since it is searching in two halves, let's look at how the binary search actually works. So first thing that has to be kept in mind is the range of inputs. The range is the set of real numbers. Why the emphasis on range is given, you will understand while the explanation for binary search is made. So looking at the example, same example like 2 minus 1, 100 plus 100 minus 10, 15, 20. Let's say this is the new example where the values or the set of values are minus 2, minus 100, 1, 100, 100, minus 10, 15, 20. So the range or the set of the numbers are from the range minus 10 to 100. So in between this range only the numbers are present. But here is the catch. Binary search assumes that the array or the set of numbers is sorted. Number has to be in the sorted order. Is sorted. And why this is essential? Because if let's say one is trying to find out the word in a dictionary, and if the dictionary order was something like Z followed by A followed by X, then the next character or alphabet is unknown or unpredictable. It can be Y, it can be P, anything. So there is no uniformity in this. And so this will become more time taking. So to reduce that time, this assumption is made, because it becomes clear in which of the halves the number or the word will be present. So based, and this is so the idea of using the number in the sorted order. So this is the original number. Now let's write these set of numbers in the sorted order, which will be basically minus 10, minus 2, minus 1, followed by 15, 20, 100, followed by another 100. Now this is the sorted order. Now how binary search actually works on this set of sorted numbers is the idea of discussion. So this is the range, and within this range some set of numbers are provided. Now since it has to be divided in two halves, so how should one divide the halves? For that, one has to use or make use of indices, and based on that the range will be divided. So let's say it is 1 based indexing, 1, 2, 3, 4, 5, 6, 7. So 7 numbers are there, and let's say according to this range is from minus 10 to 100. So from here one can see the lower bound or the lower number is minus 10. So this will have the value, or these indices will be named as low, which is set to index 1, and high, this can be set to high. Now, why indices was focused? Because one can say that, let's say 10 minus 10 and minus 2 can be 1/2, remaining can be in 1/2. So some uniformity has to be maintained, right? So for maintaining that uniformity, use of indices is preferred. And how this is divided can be done by either of the two methods. So range can be like, it can be from minus 10 plus 100 by 2. We are taking the mid value of this range. This is one approach, or way of calculating the range of the halves will be taking 100 minus of minus 10 plus 1 by 2. So this becomes basically 90 by 2, which will be, so the range of this part will be from minus 10 to 45 and followed by 46 to 100. But if you are going by this method, which will be 111, so this will be, let's say, minus 10 to 55, and from 56 to 100 it can be another range. So either of these two methods can be used to calculate the range. Now same has to be applied for the index based method. So for that, index can be calculated like low plus high by 2, or it can be calculated as high minus low plus 1 by 2. So let's rewrite this number, minus 2 minus 10 minus 2 minus 1, then it will be 15. Let's 15 followed by 20 followed by 100 followed by 100. So this is the number, and let's work out how binary search is going to be. So low and high, and let's write the range as well, which will be from minus 10 to 100. Then based on the range method of calculation, so let's say mid is taken as low plus high by 2. So here low and high is basically the indices. So this is basically indice. So this will become 1 plus 7 by 2, which will be 4. So this has to be divided like, so mid value will be at index 4. So here this is the mid value. So this, from this range to this range, either you can include the mid value. This range low to mid becomes 1/2, and mid plus 1 to high becomes another half. First half, second half. Or one can select this range low to mid minus 1 and then mid to high, it can be another half. So depending on how you are selecting the range, based on that, the elements will be divided into halves. So as far as this is concerned, the range was from -10 to 45. Then second half has the range from -46 plus 46 to 100. So one can see that -10 to 15 elements has to be present in this half. So -10, -2, -1 and 15. And this half will contain, since see if the range is 46 to 100, one cannot, so one has to put 20 here in this range. So that is the challenging part in figuring out the indices properly. So that has to be taken care. So if the another method or another approach was followed, like 7 minus 1 plus 1 by 2, which will be 3. So from this range, 20 to 100 elements will be present, and this half will have the values from -10 to 15. So here the range now changes from -10 to 15, and here the range value will change from 20 to 100. Because if all the elements were present from -10 to 100, if all the elements would have been present, then this range was correct. -10 to 45 was correct, and then 46 to 100 was correct. But since not all elements are present, hence this range value has to be changed accordingly. Now this is just the dividing part. But as said in the linear search, that there are two stages. So here let's say the query asked is to figure out whether 15 is present in this set of elements. It can be one query. Another query is to figure out whether 30 is present or not. So these are the set of queries. Now how comparison is made? Comparison is made based on the range of numbers. For that purpose, we are dividing this set of numbers into two halves. And how the division is carried? Based on the mid value and based on the range. But keep in mind that not all numbers are present, hence the range has to be changed accordingly. So let's see whether 15 is present or not. So we have divided this set of numbers. Now we know that 15 is present or not. So we will check the range. The range is from -10 to 15. So we have to search in this half, first half. So we will search in this half. And how it will be checked again? So it will be again divided. So again same method, mid has to be followed by low plus high. So in each half the range of the indices of mid will change. So here it will become 1, 2, 3, 4, and in the second half it will become 1, 2, 3. And again here -10 is the lowest value, so this will have the low, and 15 is the high value, so this becomes the high. Same with the second half, low and high. In case if there are any numbers between that, so that will become the high value. So the mid has to be calculated, so it will become 5 by 2, which is basically 2. So taking first two elements in the first half, so this half will have minus 10 to minus 2. So the range of this is from minus 10 to minus 2. And then the range will be from minus 1 to 15 in the second half. Now since 15 is to be searched, so one need to go in this direction. As stated that mid can be included in either of the half. If mid is included, then mid plus 1 to high has to be included in second half. Same has been done here. Now 15 has to be searched. So let's break it further. This process is continued till a single element is found out, because a comparison with a set of element is not possible. Hence, it has to be broken down till a single element is found out. Here, this becomes the low and this becomes the high value. The mid will be 1 and 2. So mid, low, here this is the mid. Hence, this is splitted as minus 1 and 15. And since 15 is the query asked and it is compared, hence one can say that this element is present. Now let's look for 30. 30 has to be in this half. So it will be 20, 100, 100. Then this will be low and this will be high value. The range is from 20 to 100. And remember that not all elements are present. So the mid value becomes 1 plus 3 by 2, which is 2. Now here comes the trickier part. If low, so this becomes 20, 100 in one part and 100 in another half. But since why this is included here, because in all the stages mid was included in the low part itself, hence uniformity has to be maintained here. And again this will be divided, so this will be divided as 20 followed by 100. Now these are the lowest elements, and since 30 is not present, this algorithm will report that 30 is not found. 30 not found, and so that is how the binary search is working. So this mid value uniformity has to be maintained in finding out the range as well as the mid value. So that assumption that has to be kept in mind, and another assumption, that is the element has to be sorted, has to be kept in mind. These 2 points has to be kept in mind while using the binary search. If you are using the low plus high by 2 as the range value, then same approach has to be followed. And another thing, it depends on whether you are considering mid in the low range or you are considering that mid value in the high range. So accordingly, uniformity has to be maintained. That is the idea of binary search. And this is the recurrence relation of the binary search, where we are dividing the set of numbers into two halves. And one half is for the query, and this half is for the comparison. So based on the master's theorem third case, time complexity of binary search is big O of log of n, and space complexity, because you are dividing that, but whether you are storing that is the question. If you are storing that halves, then it will be big O of n. If you are just figuring out the indices, then it will be big O of 1. So in the worst case, it can be big O of n. Now coming to the comparison from linear search and binary search, one can see that in time complexity, linear search is performing worst compared with binary search, but in space complexity, linear search is performing better than binary search. So there is always a trade-off between memory versus time. Memory here refers to storage versus computing time of an algorithm. So if you are trying to work on the time part, then memory has to be compromised. If you are working on the memory part of the algorithm, then time has to be compromised. So this trade-off has to be kept in mind while working with any algorithm. And there are also other search algorithms like the n-ary search, which will be covered in the later lecture. Hope you enjoyed the analysis of linear search and binary search. And if case there is any query or feedback, kindly post in the comment box. Thanks for watching.